Welcome back to this class. In the last session, we introduced the concept of quadratic forms. So we gave the general way of writing quadratic form in 2 variables, 3 variables, and 4 variables. So this session, we are going to see the connection between a quadratic form and matrix equation. So a quadratic form as a product of matrices. Any quadratic form Q can be expressed as a product of matrices. So the quadratic form, any quadratic form Q is denoted as Q of X is the same as X prime A X. So where X is given by actually this X1, X2 up to Xn, X prime now is the transpose of this matrix or this vector, the X1, X2 up to Xn, and A is a square matrix of the form A11, A12, A13, A1n, A21, A22, A23, up to A2n, A31, A32, A33, up to A3n, all the way up to AN1, AN2, AN3, up to ANN. So the key thing is that you should know that any quadratic form Q can always be expressed in matrix form X prime A X, where X is just this vector and then its transpose is given by this. Now let's consider 2 cases. For case where we have only 2 variables and a case where you have 3 variables. So case 1, Q of X1, X2, where we have only 2 variables in the quadratic form, X1 and X2. Now, X vector will be given by X1, X2, and then which means X prime. Actually, so that we make the difference, let this be small lowercase letters, and we show the vector by capital letters. So X1, X2, X1, X2. So the transpose of this will be X1, X2, and A will be a 2 by 2 matrix, A11, A12, A21, A22. Now, by definition, any quadratic form, so Q of X1, X2, is given by X prime A x. That's by definition. So let's put in our values. So the transpose, we have x1, x2, and then our A matrix is A11, A12, A21, A22, and our X matrix or X vector is X1, X2. Now we start, remember this is a 2 by 2, this is a 1 by 2 matrix, this is a 2 by 2 matrix, and this is a 2 by 1 matrix. So let's start by multiplying these two matrices. So remember, it's always row by column. So if you have a matrix of order 1 by 2, you multiply by a matrix of order 2 by 2, then you expect to get the result to be a matrix of order 1 by 2. So when you get the product of these first two matrices, they should be, or the matrix will be of order 1 by 2, meaning that it will have one row and two columns. So we'll have x1 times a1 will give us a11 x1, x2 times a2 will give us a21 times x2, and then x1 times a12, a12 x1, x2 times this will give us a22 times x2. So this is the matrix. And then we multiply this by x1, x2. If you have problems on multiplication of matrices, please watch the previous videos on how to multiply matrices. Now here, you see we have this matrix has order 1 by 2, while this other one has order 2 by 1. So a matrix of order 1 by 2, when you multiply by a matrix of order 2 by 1, you expect to have a matrix of order 1. So this usually comes as out. So a matrix of order 1 by 1 is simply a scalar or a function or a number. So what we get in this product, this times this will have a11 x1 squared, and then plus a12 times x1 x2 plus this one will give us a, so this, we are multiplying this element by this element here, and then so we have this by this gives us this one here, a21 by this one will give us this. So this element by this will be a12 x2 x1 plus this by this will be a22 x2 squared. So remember, this is our Q of x1 x2. Remember, x2 x1 is the same as x1 x2, so therefore that is the same as writing Q of x1 x2 is a11 x1 squared plus this is the same as a12 plus a, remember this is a, this was a21, this should be a21, should be 21, because we are multiplying x1 by this and then by this one here. So a21 then times x1 x2 plus a22 x2 squared. So this being our 1 by 1 matrix, then we can just write it without the matrix notation. So this is the quadratic form for two variables, x1 and x2. Now let's consider the case of a 3 by 3. Let's consider a case of quadratic form involving three variables. Case 2, three variables. X1, x2, x3. X1, x2, x3. So by definition, quadratic form x1, x2, x3 will be given by x prime a x. This by definition, where x is this vector with x1, x2, x3. A is this 3 by 3 matrix, A11, A12, A13, A21, A22, A23, A31, A32, A33, and then the x prime is the transpose of this x1, x2, x3. So let's input in the values into the equation. So Q of x1, x2, x3, the transpose is x1, x2, x3 times the A matrix A11, A12, A13, A21, A22, and then A23. Here we have A31, A32, A33. And then we multiply by the x vector, x1, x2, x3. So that is just inputting in the values from definition. So this is a 1 by 3 matrix. This one here, 1 by 3. These are 3 by 3. This one is a 3 by 1. So we start by these two matrices on the left. So if you have a 1 by 3 matrix, you multiply by a 3 by 3 matrix, what happens is that the order of your new matrix is 1 by 3. And then once we get 1 by 3, then we'll be multiplying by 3 by 1. And then this still 2 cancels out. So it'll be a 1 by 1 matrix, or just a number. So Q of x1, x2, x3 will be, now we expect to get a 1 by 3 matrix. So just a row vector, a row matrix. So it's usually row, column, row, column. X1 by A11 will be A11, X1 plus X2 by A21, A21, X2 plus X3 times A31 is A31, X3. So that is the first element you write. And then next one, we multiply this row by the second column in the 3 by 3 matrix. So we'll have x1 by a12, so a12 x1 plus x2 by a22, so a22 x2 plus x3 by a32, so a32 x3. So that's the second element. And then the last element will be x1 times a13. So we'll have a13 x1 plus x2 times a23 will be a23 times x2. x3 times a33 will be a33 times x3. And then you close this and you multiply by the vector x1, x2, x3. So the resulting matrix in this product of the two matrices on the left is a 1/3 matrix. So 1/3, and this one is 3/1, then multiplication is defined. So next, so it'll be, is always row by column. So it will be all this multiplied by x1 plus all this multiplied by x2, and then plus all this multiplied by x3. So you have q of x1, x2, x3 is a11 x1 plus a21 x2 plus a31 x3. This element you multiply by x1 plus a12 x1 plus a22 x2 plus a32 x3. This element you multiply by x2. And then because it's a 1/1 matrix, then there's no need of writing the matrix notation back. So that's why I'm just writing like the equation. A13 x1 plus A23 x2 plus A33 x3. You multiply this by this element x3. So the next thing is that now to simplify this. So we have q of x1, x2, x3 will be now a11 x1 squared. And then from this one, I get, when I multiply x2 by this element, I get a22 x2 squared. So I've taken care of this. This one here plus a33 x3 squared, this by this. I've taken care of this. Plus, now here I'll have x2 x1, and here I'll have x1 x2. So I bring them together. I write a12, this one here, plus a21, this element here, and then you multiply by x1 x2. So this one is taken care of, this one is taken care of. And then this one here, a31, this will be x3 x1, and then here I'll have x1 x3, do the same thing. So I'll have a13, this one here, plus a31, this one here, and then you multiply by x1 x3. So I'll have taken care of this, I've taken care of this. Plus, I come here, 3x3 x2, I only have x2 x3. They're the same, only that the order is interchanged. So I'll have a2 3, this one here, plus here I'll have a3 2, multiplied by x2 x3. So this will be the quadratic form that we were interested in. So a11 x1 squared, a2 2x2 squared, a33 x3 squared, a12 plus a21 x1 x2 plus a23 a32 x2 x3, and then a31 plus a13 x1 x3. So this is the quadratic form for three variables, x1, x2, x3, as it should be. And then next thing you say, let's call this one 1. We can similarly define the quadratic form for 4 variables in the same way. So we say a1, 2 and a2, 1 are the coefficients of x1, x2. So it means that a1, 2 plus a2, 1 are coefficients or are coefficient of this x1, x2. In general, if we have aij and aji are both coefficients of xi, xj, whenever I and j are not equal. So aij plus aji are both the coefficient of the element xi times xj. Now, with this, we can say if we let us have a new coefficient let's have new coefficients of xi, xj as cij, which is the same as cji, and we define it as a half of aij plus aji. Let's simply average of these two values, aij and aji. Now, from our study on symmetric matrices, so we know that a half of a matrix plus its transpose is a symmetric matrix. Can call it C. Remember this, these are lowercase letters, they are small c's. These are lowercase c's. So when you get the average of a matrix plus its transpose, you get a symmetric matrix. So that's in general, from that information, so we can say that's the coefficient matrix in quadratic form is always symmetric matrix without loss of generality. That is always the case. So thus, then Q of x1, x2, x3 is the same as x prime a x, and for this case we write C11 x1 squared plus C22 x2 squared plus C33 x3 squared plus 2 C12 x1 x2 plus 2 C23 x2 x3, and then plus 2 C31 x3 x1 or x1 x3. Uh, 3 1 x1 x3 is a quadratic form for that case of 3 variables x1 x2 x3 with Cij defined as a half of the Aij plus C plus Aji. So the matrix A is known as the coefficient matrix or matrix of the quadratic form. So that is the analysis on how to transform a quadratic form into matrix form. The next session, we do an example on how to do that transformation. Thank you.